continuity of the function here. First, whenever you observe that these three graphs you observe here. So by the observation itself, you will come to know that which function is. This graph represents the continuation. Whenever you are drawing this graph, you need to lift the pen here, from here to here. So that's why this graph says that the function which is representing this graph is not continuous. And this graph is also not continuous because there is a gap between here. Okay. And whenever you see that graph, and it is continuous. So by the graph itself, you can say that it is continuous. So f of x is equal. These two are discontinuous functions, and that function is a continuous function, which is representing whatever it may be that whenever you are drawing the graph of the function, continuation, whenever you draw that, a function is continuous at x is equals to c, particular point is defined at x is equals to c, such that limit extends to c, f of x is equals to f of c. So limit means first limit should exist at that particular point. Limit should exist at that particular point. Let us see that the that continuity of the functions which is defined to you here, f of x is equals to 2, 3. When x is less than or equal to 0, it is 2, and x is equals to 3 if x is greater than 0. So this is the situation. So whenever it is given that function, first you need to understand here. What is a function definition? Suppose if x values, what is f of 0? Can you say what is f of 0 from this? What is f of 0 from this function? Yes, f of 0 is 2. And here, whenever you are here, it is checking the value of the f of x is 2 at x is equals to minus 0.01, minus 0.001, minus 0.001. It is 2. So that is nothing but the left hand limit. Left hand limit is 2. Left hand limit means left side of the 0. 0 for left side, whatever the value you are taking. What is the meaning of this representation? Left hand limit. We call it as a left hand limit. So limit extends to 0 minus f of x is equals to 2. Why? Because left side of the 0, the function gives the value as a 2. So any value you take, it is equals to 2. And in the same way, the value of the f of x you take into consider. Value of the f of x is equals to 3 if x value is greater than 0, 0 to greater than. And whenever you observe, this function is actually a split function. It is a split function at 0. So at the place of 0 limit, whenever you are finding, left hand limit and right hand limit should be taken into consider. Otherwise, remaining all the places, whenever you see that, suppose x is equals to 5, you take into consider. At the place of x is equals to 5, it is left hand limit and right hand limit will give you the same answer, because left side of the 5, right side of the 5 is nothing but both are greater than 0 only. So it always gives the 3 only. So no need of finding left hand limit and right hand limit in that situation. Left hand limit and right hand limit. Here, as it is equals to 0, 0 it is given to you. So whenever it is given to you 0, x is equals to sorry. Okay. So x is equals to 3. The values greater than 0, wherever you take the values greater than 0, we are going to get it as f of x is equals to 3. And what is meaning of this one? The right hand limit of the limit extends to 0 plus f of x is equals to 3. And when you see that left hand limit is 2, right hand limit is 3. Left hand limit is 2 and right hand limit is 3. And both are not equal. If both are not equal, then you can say that limit does not exist at x is equals to 0. X is equal to 0 placement, limit is not existing. When the limit is not existing, this value is not at all equals to the function value f of 0. F of 0 value is what here? 2. In case if you get f of right hand limit also equals to 2, then limit exists. Limit exists. When it is limit exists, you need to see that whether its value is equals to f of x or not. So in that situation, second one, whenever you consider that left hand limit is equals to 2 and right hand limit is also equals to 2. Why? Because this is a very different function. Here it is given not equals to. Left hand limit is nothing but left side of 0. Left side of 0 is 2, right side of 0 is 2. But at the place of 0, the value is 1. So this is another situation, limit existing, but it is not equals to the function value at that particular point. In this situation, limit existing, but it is not equals to the function value, whatever the value is given to you, the function value ko equal nahi. So that's why you can say that in that situation also not continuous. Coming to the third part, left hand limit is equals, because it is for all x is equals to r. What type of the function it is called? Types of the functions. Which type of the function this is? Because this is continuous function at a particular point. It is a constant function. Because for all x is equals to 0, real numbers, it is equals to 1, it is given. Okay. Now, suppose f is a real function and a subset of the real numbers. Let's see is a point in the domain of f. Then f is continuous at particular point c if limit extends to c, f of x is equals to f of c. Limit extends to c. So, particular point pe continuous. That is nothing but previously, whenever you say that 0 point, first two problems में 0 पे continuous नहीं. It is not continuous at x equal to 0 in the first two cases. So if f is not continuous at x equals to c, then we say that it is discontinuous at a particular point. So let us check the continuity of this function at x equal to 1. At x equal to 1, the function is given to you that 3x plus 1. The function is given that 3x plus 1. So 3x plus 1 continuity, let us check at x equals to 1. So it is a very simple thing that what you need to do, limit extends to 1 minus is nothing but left hand limit at x equals to 1 you need to find out. Right hand limit at x equals to 1 you need to find out. And left hand limit, right hand limit both are equals to the same. So that's why directly it was taken that limit extends to 1 is taken. It is not a split function. Do remember that. In the previous problems, it was taken that left hand limit find out kar diya, right hand limit find out kar diya. But it is not a split function. Split function already I told you what is meant by a split function. Split function bole to kya hai? At that point, the function is variation is having x equal to 0 का less में 1 है, greater than 0 1 है. So here it is not like that. So this situation you see. Let us check the continuity of this function. It is a split function. This is a split function because it is two different expressions are given to you in this situation. So we call this function as a split kar diya. So left hand limit find out karna hai, right hand limit find out karna hai, and both here actually left hand limit and right hand limit whenever you take into consider what value f of 2 value is equals to 6 here you are going to get, but here left hand limit right hand limit find out nahi kar rahe because both are equal you are going to get it for the less than 0 greater than 0 less than 2 greater than 2 you need to take the function is this one only. Function is not less than 2 alag greater than 2 alag nahi hai. So that's why directly the function is taken into consider. Now next function is sin x. Sin x whether it is a continuous function in the interval of the graph. Whenever you see the graph of this function, it is continuous 0 to pi. You are going to have the graph of the sine graph will be like this, here to here and pi up the next 2 pi, like that we are going. But 0 to pi only it is asking you to check the continuity. So whenever you take that in the 0 to pi graph observe kar liya, it is continuous function. Graphically whenever you see that, and f of x value is equals to sin x is continuous in this domain continuous. It is continuous in the domain is nothing but it should be continuous at every point in the domain. Continuous function in the given domain. One domain is given to you. In the it is continuous in the given domain is nothing but it should be continuous at every point in that given domain. So here 0 pe check karo. 0 plus whenever you take it the value is 0. That is equals to f of 0. And pi minus whenever you take pi minus pi plus both are equals to the 0 and it is equals to f of pi. Means extreme points pe check kar le. Hence the function is continuous at the end points. It is continuous at 0. It is continuous at the point pi. These two are end points. So it is continuous in the both points whenever you are taking it. Function it can be considered in that domain. It is continuous every day. So the continuous. Okay. So next, let us check the continuity of the. Let us take the continuity of the infinity concept. This is also very much important actually. We have discussed the plus infinity, minus infinity, we used to say that. And there is a most confusion among the students that plus infinity, minus infinity, and whenever 1 by 0 value, what is this one? Limit is introduced with the help of this one only actually. So the function is taken as a 1 by x. If you take the f of x is equals to 1 by x. So limit extends to 0 plus f of x, limit is equals to what do you get? And when you observe that 0 plus is nothing but 0 say greater than and near to 0 values should be taken back. So it was started from the 1. 1 से start कर लिया है x value 1, 0.5, 0.2, 0.1, 0.001 and so on continuously 10 to the power of minus n is taken. The f of x value, whenever you see that, it is going on increasing. Either the 1 है, here 2, here it is 5, here it is 10, here it is 100 and 1000 and go on 10 to the power of n, you will get. As the value of the x is going on decreasing, near approaching to the value 0, as it is approaching to the value 0, then you can say that it is the f of x value is going on increasing. So it is increasing how much? We cannot say. As it reaches near to the 0, the value increases to the very bigger number. So that's why we represent that for a positive real number very close to the 0, the value of the function will be a large number. So this large number is represented by the plus infinity. So it is infinity is nothing but it's not a number actually. The representation for the greater number. It's a very big number. So that represent करने के लिए. And let us see that when the value here limit extends to 0 plus f of x is equals to, we write it as a plus infinity. And whenever you consider that right hand limit of the function f, it does not exist. We call it as a does not exist. Plus infinity means it is not a particular value, you are not going to get it. Particular value you are not getting. So that's why we say that right hand limit of the this function at 0 is does not exist. And left hand limit, later whenever you check that, left hand limit is nothing but you should go on increasing the value near to the 0 by taking the negative values. Left side of the 0, left hand limit whenever you, ये left hand limit. So minus 1 से start कर दिया. On the number line you take the number line, here 0 will be there. Minus 1 से start करके the value is going on increasing. And increasing only, this is increasing only, the minus 1, minus 0.5, minus 1 say minus 0.5 is greater. So when it is going on increasing, this value going on decreasing. As it increases more, the f of x value, 1 by x value decreases that much smaller. So it is represented by the minus infinity. Minus infinity is nothing but very small number. To represent it is very small number, we use the symbol minus infinity. So limit extends to 0 minus, we will write as a minus infinity, but it is does not exist. Why it does not exist? It's not a particular value. You are not getting particular value. एक number नहीं आ रहा है आपको. Different values you are going to get it. So whenever you say that limit extends to 0 does not exist. So here left hand limit and right hand limit both are not here equal, you are getting. One is plus infinity you get, another one minus infinity. So that's why you can say that it does not exist at x is equals to 0. So when you observe the points here, different points observe kar lo here whenever it is given to you. So here at 1 by x value here, see points are given to you whenever these points are given to you. So here the value is not at all increasing here. Whenever it is value इधर से लेके 0 को approach हो रहे तो increase हो रहा है, but it is not touching the 0. So very big number you are going to get it. In the same way like that. Tan function whenever you take, tan function also, whether it is continuous or not, tan 0 degrees whenever you take 0, tan 45 degrees 1, and value when you reaches in 90 degrees, the value is infinity, you are going to get it. Very big number you will get it here. But here that is actually tan 90 degrees should be said as a undefined. Tan 90 degrees को क्या बोलना है? Undefined बोलना है. But whenever it is given to you, limit extends to 90 degrees tan x if it is given to you. It is undefined. Because limit concept you need to understand very clearly. Limit is nothing but not exact value. When it is approaching to the near to the 90 degrees, what is the function value? So for very angle very close to the 90 degrees from the left side, the value of the function will be a large number. So therefore, whenever you write the plus infinity, large number it will be taken. And whenever you are taking 180 say 90 को approach for 180 से 90 को approach for, तो भी the value is, it is infinity only you are going to get. So value is decreasing here. Whenever you see that 180 degrees, 150 degrees, 120 degrees, and so on till the 90 degrees, if it comes to you, the function value. So for the any angle very close to the 90 degrees from the right side, 90 degrees ka right side say, whenever you are taking 90 degrees ka right side, so 180 say, so the value is going on decreasing, but it is not at all touching. So the number is represented by the minus in that is minus infinity is only the representation. Very smaller number only. So here we are going to get limit extends to plus infinity minus infinity. You are going to, that's why you are going to say it is does not exist. And will say that you are taking into consideration. So it is where the algebra of the functions, limit of the continuity of the algebra of the functions. Sorry. So good morning, sir. Sir, can you hear me? Hello. Hello. Is it audible, beta? Students?
Yes, sir.
Ria, can you? Okay. So welcome to the principal, sir, inspecting principal, sir. Radhacharan, sir. KV, Naipi, Naipa.
Thank you, sir. Thank you.
Oh, okay, sir. Shall I continue, sir?
Oh, you continue, please.
Okay. So here, algebra of the functions, continuity of the functions, two functions whenever you are taking into consider, limit extends to c f of x is equals to f of c. Till now we have seen that continuity of the function. Now algebra of the continuity of the functions we are seeing that. So limit extends to c f of x is equals to c and limit extends to c g of x is equals to c whenever you are taking into consider. Let's take the continuity of the function f plus g. So sum of the two functions whenever you are taking into consider, that is f of x and g of x are the continuous at a particular point c. If they are continuous. So f of x and g of x are defined at c, and then f plus g of x is also defined at c. So sum of the two functions, whenever you consider f of x is equals to x square and g of x is equal to some x cube, if you are taking into consider, the sum of the two functions is nothing but x square plus x cube. X square plus x cube. So like that here, sum of the two functions whenever you are taking into consider, limit extends to c f of x plus g of x you are going to get. Limit extends to c f of x plus limit extends to c g of x you are going to get.
ये
So
तो पढ़ा रहे हैं
this is
आप क्या लाइव क्लास हो गई
this is equals to f of c. Already it is defined, it is f of c, and this is equals to g of c. So g of c. So sum of the two functions whenever you are taking into consider, this is two functions are satisfying. Some of the two functions are satisfying. That means whenever the two functions are continuous, then some of the two functions are also continuous at a particular point, because it is equals to limit extends to c f plus g of x is equals to f plus g of c. You are going to get it. So that's why you can say that f plus g also continuous. In the same pattern, whenever you take into consider difference of the two functions is also continuous. You are going to do. Let's take the continuity of the function f minus g at x is equals to c. So same pattern you are going to have, just difference you are going to have. Okay, and product of the functions also in the same way they'll be continuous, and the division means quotient of the functions also continuous. You are going to get it. So see here, f minus g of x is also defined at particular point c. So it is defined. So when it is defined, we are going to check the limit extends to c f minus g of x. Limit extends to c f minus g of x. So this can be written as limit extends to c f of x minus g of x. The limit extends to c f of x minus limit extends to c g of x. We are going to get. So limit extends to c f of x separately and limit extends to g. And limit extends to c f of x is already, it is defined and it is equals to f of c, and that is g of c. You are going to get it. So this is f of c and this is g of c. F of c minus g of c, you are going to get it here. Okay. So f of c minus g of c, you are getting. And whenever you are considering the difference of the two functions also, the same pattern you are going to get it. This can be written as f minus g of c. F minus g of c. So limit extends to c f of f minus g of x is equals to f minus g into c. So in the same pattern, you are going to have the product of the two functions and the quotient of the two functions also you are going to have. So product of the two functions, whenever you see that product, we are going to get it like this, f into g. So this satisfies the product of the two functions also. Means when the two functions are continuous, their sum is also continuous, their difference is also continuous, their product is also continuous. In the same pattern, their quotient also is continuous. You are going to get same pattern. You can continue that. You can check the difference. See, quotient of the functions is continuous. So it is very simple part to you to understand here. So that's why I'm skipping this one. And here two functions. So algebra of the two functions, whenever you are algebra of the continuity of the two functions, whenever you are taking into consider sum of the two functions, continuous means first two functions are continuous means sum of the two functions is also continuous, and two functions are continuous and difference of the two functions is also continuous, and product of the two functions also continuous, and quotient of the two functions defined that g should not be equals to 0. G should not be equals means the function whatever it is having in the denominator should not be a 0. So then only then you can say. So special cases what your f of x is equals to some constant where k is a real number. Some constant is if it is taken into consider. So this is one special case you are going to have here whenever you are. So f of x by g of x is nothing but in case k is a constant means the numerator function whatever you are taking into consider that is a constant, k by g of x is also a continuous. Okay, so g of x is continuous at c and k is belongs to the real numbers, then k by g of x is also continuous at that particular point, provided that g of c should not be equals to 0. It should not be equals to 0. If k is equals to 1, then 1 by g of x is also continuous. If k is equals to different functions. Now let us define the derivative of the functions, which is very much important to you. With the help of this only, the derivation. Most of the students actually, they know the derivation formulas. You people also normally, whenever I ask d by dx of sin x is nothing but cos x, you will say. You have learned already, these are all in the first principle. Using the first principle in the 11th class, you have learned. So that is itself is the derivative of the real function f at a continuous point c in the domain is defined by limit h tends to 0 f of c plus h minus f of c by h. This is called f dash of c. We represent that one by f dash of c. This is represented by f dash means derivative of the particular function, derivative of the particular function at the point c. So that is it. This is derivative of the function, completely function. So the difference is here c you are going to have, here x you are going to have. So this is called the first principle. Usually we call it as a first principle. And we can prove the derivative of the x to the power of n. What is the derivative of x to the power of n, student? Yes, nx to the power of n. What is the derivative of the sin x? What is the derivative of the cos x? What is the derivative of the tan? What is the derivative of the tan x? You online students also can give the response. Derivative of the tan x? Yes, these are all you can. Yes, very good. These are all already we have proved using the first principle. That is called the first principle. Using that first principle, we have proved in a yes in a 11th class itself. So that's why here it is not necessary to you to discuss all that one. So at a particular point, differentiability is nothing but limit h tends to 0 f of c plus h minus f of c by h, and it is represented by f dash of c. The value we are going to substitute in that function after derivating that function. After derivating that function, we are going to see. So that is that left hand limit, normally left hand limit and right hand limit. Limit exists hona hai to, limit exists hona hai to left hand limit and right hand limit should be equal. So both should be equal here. So left hand limit and right hand limit both are equal hona hai. That is, this is left hand limit of that particular function and right hand limit of the particular function. And both the functions whenever you are taking into consider. So a function f is said to be differentiable in the particular interval a comma b if it is differentiable every point. This is the differentiability of the function at a particular point c, and this is in a given domain a comma b in an interval. It is called a differentiable if every point in the between these two, every point if it is differentiable, then you can say that it is differentiable. So f dash of a is called the right hand derivative of, and f dash of b is called the left hand derivative of the function, because this is a left side you are having, left at extreme points. These are the extreme points of the given domain. So a function is differentiable at a particular point c, then also it is continuous at that particular points. So continuity already we have discussed. Differentiability and continuous difference is what? Continuous is nothing but limit should exist and that should be equal to the function value at that particular point. At that particular point, it should be equal. So now here, given that, let us see this theorem, given that function is differentiable at a particular point c. So by the definition, you can say that f dash of c is equals to limit x tends to c, f of x minus f of c by x minus c, as per the definition of the first principle, using the first principle normally. So now here for x is not equals to c, we have f of x minus f of c is equals to, can be written as x minus c multiplied and divided here. So what do you get here? Limit extends to c of f of x minus c, find out karo. This is equals to limit extends to c f of x minus limit extends to c f of c is equals to limit extends to c f of x minus f of c into limit extends to. This value we are going to get it as a 0, and this is represented by f dash of c using the first principle definition, f dash of c. So into limit extends to c, x minus c value is 0. So then you can say that it is equals to 0. This theorem is very simple theorem here. Nothing else here you are having. Continuous differentiable already it is given to you. Differentiable already it is given to you and asking to you to prove that continuous. By giving the differentiability, it is continuous. So continuous definition is what? Limit extends to c f of x is equals to limit extends to c f of c. So this value is equals to f of c. Whenever you see that this value is, because this function is what here? Constant function. F of c is nothing but constant. So limit extends to c a constant value, constant function. Whenever you are constant expression means expression when you are taking, the value is f of c itself you are going to take it. So we are going to say that all the differentiable functions are continuous, but the converse need not be a true. Means if a function is a continuous function, it may not be differentiable function. So for that, let us see that one example here, f of x is equals to modulus of x minus 1 is taken into consider. So clearly f of x is a continuous function at x is equals to 1. Why continuous function? How the graph of the this function will be there? Continuous. When you draw the graph of the function also, when you draw the graph of the function also, see, let us draw the graph of this function. So first, let us draw the graph of this function. Suppose how the graph of the function modulus of x minus 1 will, mod x graph will be, whenever you take the x-axis and y-axis into the consideration, okay, f of x is equals to mod x. So can you write, suppose let us take the only the mod x here. Continuous function is nothing but how the value of the graph how it shows to you, you need to know that one. Already you know that graphs of these functions you learn in 11th class only. Once continuously is nothing but you can say that f of this can be written as in another way. F of x is equals to modulus of x can be written as f of x is equals to x if x is greater than or equal to 0. It is equals to minus x if x is less than 0. And most of the students will get confused here at one point that, sir, modulus of any function should not be negative. No? This is minus x is negative. Already I told you. This is only the revision class only. Already I told you minus x is negative or positive. Let me ask one question to you. Whether minus x is positive or negative. Minus x is negative or positive. Yes, whether it is right or wrong, you say. Doesn't matter. Very good. It can be negative or positive. We cannot say that. In this situation, here it is C. X is negative. X is negative means minus x is positive. So that means we are going to get the positive values one. And mod x graph, whenever you observe that, at the place of 0, 0 hoga. Minus 1 ka place mein 1 hoga. Suppose if you take the minus 1 and 1 ka place mein 1 hoga. Most of you see here, most of the mathematical problems, when you solve graphically, graphical representation, whenever you see that, and graphically, whenever you represent that, the problems becomes very easy to solve problems. So that is very much important. Please try to draw the graph of the given function, every function, so that it is an easy task for you to solve the problem, whatever it may be, it is given to you. Okay, let us see here. What do you get here? And if you take the 2, approximately 2, you are going to get here minus 1, here 2. So positive in the first 2 quadrants only you are going to have. So the graph will be like this for mod x. X minus 1 graph will be whenever you are taking f of x is equals to x minus 1. At the place of 1, we are going to have the like this V shape. So this is a graph of the f of x is equals to mod x minus 1. And you observe this graph. Observe this graph, it is continuous. Isn't it? It is continuous or not? So continuation is there. So you can say that it is continuous. How do you say it is continuous normally? This is graphically I said that it is continuous. And how do you say that normally continuous bolna hai to what to do? Limit extends to 1. What to prove? Limit extends to 1. F of x should be is equals to f of 1. Limit extends to x. Limit extends to 1. F of x should be equals to f of 1. So then it is called continuous. So that also actually here it is given to you that f of x is continuous. Clearly it is continuous. But वो भी continuous already we have solved it. That's why it is given to you that it is continuous. But you need to know that how do we prove that it is continuous? Because this function is a split function. Whenever you consider that this function is a split function, because can you define the function right another way? This function f of x is equals to mod x minus 1, like this. F of x is equals to dash, is equals to dash. If x is greater than or equals to 1, if x is less than 1. Here x greater than 1 means x minus 1. Minus of x minus 1, that can be written as 1 minus x. So now here, actually what to do here? You need to find out limit extends to 1 f of x. Limit extends to 1 f of x find out karna. So what do you write here? Limit extends to 1 minus f of x you need to take. Once a less than, then the function is we are going to get limit extends to 1 minus f of x is nothing but the function this one or this one we need to take. Second one, because it is approaching to the 1 but less than 1. It is approaching to the 1 but less than 1. So approaching to the 1 less than 1 is nothing but 1 minus x should be taken. But do remember that most of the students will get confused here in this point that 1 minus whenever you are taking, minus 1 substitute correct. No. You are not supposed to substitute the minus 1. What is the meaning of this one? 1k left side whenever you are reaching left side values you are taking near to the 1, left side of 1 whenever you are taking, how the function behaves 1 minus x. So the table I have given to you, like the table you can take into consider, and the value whenever you observe that it reaches to near to the value 0. So that's why we say why it reaches to the 0 means just one substitute karo here. 1 minus 1 kya hoga? 0 hoga. Limit extends to 1 plus f of x. So limit extends to 1 plus f of x. F of x is nothing but here. X plus is nothing but x minus 1 should be taken. Here also you are going to get 0. So both are equal. Therefore, limit extends to 1 f of x. F of x is nothing but mod x minus 1 is equals to 0. And this should be is equals to f of 1. What is f of 1 value? F of 1 means 1, this one, x minus 1 only should take 1 minus 1, which is equals to 0. So it is equals to 0. So therefore, this is 0 and this is also 0. So both are equal. Actually, you need to prove that, you need to know this one. So, but it is already learned in 11th class only. That's why it is given to you directly. Clearly, it is, we know that it is continuous. So now what to do here? Differentiability, you have to check it. So let's evaluate the left hand derivative and right hand derivative of the function at x equal to c approaches to the 0. So left hand derivative and right hand derivative you need to find out here. So left hand derivative का formula क्या है? Limit h tends to 0 minus f of 1. Here we are finding at the place of 1. So as we are finding at the place of 1, we are finding at the place of 1 plus h2 1 tak you have to consider. 1 plus h2 1. So here 1 f of 1 plus h. As we are finding at a particular point C, we used to say. So at a particular point C is nothing but here the point is taken as a 1. So that's why 1 plus h should be taken into consider. And see how the function behaves in this situation. So here limit extends to 0 minus f of 1 plus h you need to take into consider. This I am erasing. 0 minus. So when you consider here also, you should be very careful here. 1 plus h minus 1 is taken into consider. 1 plus h minus 1. Already I told you the function is given to you. So here 0 minus, whenever you are taking, the function should be taken as a 1 plus h. In this situation, 1 you are going to get, and left hand limit, right hand limit difference you are going to get. Left hand limit and right hand limit, different limits you are going to get. In the same way, derivative of the composite function and implicit and inverse trigonometric functions all we are going to have. So now here, derivative of the composite function is f of x is equals to x minus 3 whole cube. This is a one another situation. Okay. So first what you have to do, derivative of that particular function expand भी कर सकते हैं x minus 3 whole cube and individually एक एक function को derivative करना पड़ता है. So this is derivative of the function composite function, or you can do this function derivative by doing the x minus 3 you consider as some t. Suppose if it is 50 given, 50 expansion cannot be done. 3 means we have x minus 3a minus b whole cube expansion you did. Okay. And whenever you take the f of x is equals to x minus 3 whole cube, 50 is given means how do you find out the derivative of this function? We cannot expand and we cannot find out. So in that situation, this is called compositor. Chain rule you have to use in this situation. So what is the chain rule says to you that f is a real valued function which is a composite of the two functions, and u and v, that is f is equals to composite function u o circle v. Normally composite functions is here it is given to you. So they like this. Okay. So composite functions we have to, using the chain rule we have to do it.